Okay, you guys, last time was homework number 49 up there, page 376, 21, 23, 25, 27, and page 380, 1 to 4 all, 9 to 12 all, 21 and 22. Now the ones on the first page on the 376 is similar to ones you did on previously on the previous assignment, and it's similar to the ones like 1 through 4, so I'm not actually going to do any of those problems. I'm going to do some of the ones from page 380. In fact, the ones I'm going to do are number 2, number 10, number 11, and number 22. Those are the ones I'm going to do. Now, I also am sending out the answer key that has all of the problems worked out. So if you have any questions, including the ones from the first page, they're all going to be worked out on the answer key that I'm sending you guys. So if I don't do your favorite problem, look at the answer key. It'll be worked out there. Okay, so here we go. Let's start with number 2. The directions here are to create an equation that has these two guys as roots. Okay, so we're going to invent an equation that has these guys for the answer. Now, there's only 2 roots given right here, -2 and -1 plus I. But by the conjugate root theorem that we learned last time, we also know if -1 plus I is a root, its conjugate, which is -1 minus I, also would have to be a root by the conjugate root theorem. So that's going to be another root that we get for free just using the conjugate root theorem. So now I've got 3 roots. Remember, I could use my magic formula, x squared minus the sum of the roots times x plus the product equals 0, on 2 roots at a time, not 3 roots at a time. So the smart choice is going to be, let's use these 2 together and find their sum and their product. So the way I'm going to do that is the sum is, if you add these together, the I and the negative I cancel. -1 and -1 is -2. The sum's -2. The product we have to do FOIL on. And this turns out to be -1 times -1 is 1, plus I minus I squared. But remember, I squared is a fancy name for -1. So it's going to be minus -1, which nets out to be +1. And these guys cancel. So the product is 1 plus 1, which is 2. Okay, so that's the product. That's the sum. And remember, the magic formula is x squared minus the sum. So it'd be minus -2x, which is plus 2x, plus the product, plus 2. This polynomial right here has these 2 roots, okay? But we don't just want a polynomial that has those 2 roots. We want it to also have -2 as a root. So I would multiply it by the factor that would give me -2 as a root. We've talked about this before. The factor that goes with the root of -2 is x plus 2, right? So times this polynomial by that polynomial, set it equal to 0. That will be my answer. So let's go ahead and multiply it out. X times x squared, x to the 3rd plus 2x squared plus 2x, that's x times each of these. Now I do 2 times each of these. 2 times x squared is 2x squared. 2 times that is 4x. 2 times that is 4. Notice I'm lining everything up. 3rd power, squared power, single power x, constant. Add these together. Okay, trying to switch up the colors for you guys. X to the 3rd plus 4x squared plus 6x plus 4, set it equal to 0. This polynomial, or this polynomial equation, has those 3 roots. It's that easy. All right, so that's number 2. Okay, the other ones were similar to that. Okay, number 10 gives us a polynomial equation, 3rd degree equation. There's going to be 3 roots. One of those 3 roots is I root 5, they're telling you. Well, by the conjugate root theorem, if I root 5 is a root, then -I root 5 would also have to be a root. So we're going to do the same thing we did over there, the sum and the product. Now the sum is negative I root 5 plus negative I root 5 is just 0. They just add up to 0. Okay. The product is going to be, watch, I root 5 times negative I root 5. Okay, I'm going to show you how I do this. Okay, positive times negative is negative. I times I is I squared, and square root 5 times square root 5 is just regular 5. So it's negative I squared times 5, but I squared is negative 1. So it's going to be negative 1 times 5. Well, that's negative times negative is positive, so that all just multiplies out to be 5. So the product is 5, the sum is 0. How do you create a polynomial that has those two guys? Whoops, wait a second here, whatever. How do you create a polynomial that has these two roots given the sum and the product of that? It's going to be x squared plus 0x or minus 0x, however you want to look at it, which is nothing. You don't even have to list it, plus the constant 5 equals 0 or whatever. So that is the polynomial that would contain those two roots. Let me grab this. Okay, now, well, you know what? If this polynomial contains those two roots, and this polynomial also contains those two roots, that means that if I divide these out, now since this is a squared, I'm not going to be able to use synthetic division. I'm going to have to use long division. So if I do long division on this guy divided by this guy, it will suck those two roots out. The remaining root will be my last and final root. So here we go. I'm going to do long division on this. X squared plus 5 on the outside. On the inside, 2x to the third minus x squared. I'm checking to make sure no powers are missing. If there's any powers missing, I got to put zeros in there, but there's not. So I've got it up to there. Now, here goes the calculations. Okay. So what does it take to turn x squared into 2x to the third? It's going to take 2x. So I put it right above this x, 2x. Then I multiply this times this, 2x to the third. Yay, just like I was expecting. Good news. This times this is 10x. Notice I'm skipping the squared because there was a 0x here. We're skipping the x term here. That's going to make us skip this term because 2x times 5 is just 10x, which I put over here. Just leave that blank because you could have put a 0x in there if you wanted to, or you didn't have to. If you put a 0x there, you'd be putting 0x squared right here. So it doesn't matter to me which way you do it, as long as you do it correctly. Okay, so now we want to subtract that. So I'm going to say subtract that. But remember, subtracting is the same thing as adding the opposite. So make that a plus, make that negative, and that negative. Now, add these together. This should always wipe out. Every time, the first one should wipe out, okay? What's negative x squared and nothing? Negative x squared. 10x and negative 10x is nothing. And then, so that's what we get there. Bring down the next guy, bring down the negative 5, and then we say, okay, what does it take to turn x squared into negative x squared? And that is going to take a negative 1. So I put negative 1 right there. Negative 1 times that is negative x squared. Negative 1 times that is negative 5, right? Skip the middle term, right? And then subtract that. Oh my gosh, believe it or not. Plus, make that a plus, make that a plus. Nothing, nothing, no remainder, which is exactly what I expected. If there was a remainder here, there would be a problem, but there's not, so there's no problem. What does that mean? That means the other root is sitting inside of that guy. So what do? Set that guy equal to 0 and then solve for x, and that's it. I'll be done once I do that. So I know you guys are excited. We're going to find it out. In fact, I can tell you what that root is. It's going to be opposite this over this, positive 1/2. Watch. Add 1, 2x equals 1, divide by 2, x is 1/2. Son of a gun, can you believe it? All right, so the answer is, because the book likes you to list the entire solution set, so obviously the 1/2 we just figured out here, along with both of these guys, right? Plus or minus I root 5. There is the entire solution set, which is 3 answers. 1/2, positive I root 5, negative I root 5. A third degree equation should have 3 roots, and it does. How about that? All righty, moving along. Number 11. Now notice number 11 is a 4th degree equation, but they're only giving us 1 root. But fortunately, we know something called the conjugate root theorem that says if 3 plus I is a root, its conjugate, 3 minus I, will also have to be a root. So what does that mean? That means I can create a polynomial that contains those 2 guys. So I'm going to do that. Their sum is clearly 3 and 3 is 6 because these cancel. The product is 3 plus I, 3 minus I. That's going to be 9 minus 3I plus 3I minus I squared. But remember, minus I squared is like saying minus negative 1, which is a plus 1. These guys cancel. So 9 plus 1 is 10. Product 10, sum 6. So if I want to know the polynomial that contains these 2 guys as roots, it would be x squared minus the sum, so minus 6x plus 10. That polynomial contains those 2 roots, okay? Guess what? This polynomial also contains those 2 roots. So that means that if I divide this guy by this guy, it should go evenly, and I will be able to figure out the other 2 roots. So here's how it works. This guy on the outside, x squared minus 6x plus 10. And on the inside, we have x to the 4th minus 6x to the 3rd. Wait a minute. There ain't no x term. There ain't no x squared term. Son of a gun, you need to put 0x squared in there. If you don't, you'll be in trouble. Plus 60x minus 100. Don't forget the 0. It's going to mess you up. Okay, here we go. Ooh, I'm getting excited. Now, what does it take to turn x squared into x to the 4th? Just simply x squared. Good thing I put that 0 there, or I wouldn't have anywhere to put my x squared. Good thing I did. X squared times x squared is x to the 4, yay. This times this is minus 6x to the 3rd. Ooh, interesting. This times this is plus 10x squared. Subtract. Okay, wait a minute. Now, what happens here? Well, I will tell you. First of all, I don't like to think of it as subtracting. I like to think of it as adding the opposite. So make that plus, negative, plus, negative. This is 0, but wait a minute. This is also 0. Now we expect this to wipe out. If this doesn't wipe out, there's a problem, okay? But guess what? We don't expect this to wipe out. It just so happened. It could happen. So I have 2 options here. I could call this 0x to the 3rd and say, what does it take to turn x squared into 0x to the 3rd? And I could say 0x, and I could put a 0x right there. That's one option. But also, if it's just 0, it's like nothing. So you could just ignore that as long as you just realize, oh, there's like a 0 there, so I'm going to have to go over to the next thing. So that's what I'm going to do. So anyways, we got that. Now, 0x squared minus 10x squared is minus 10x squared. Now, we were going to bring down the 60x, but since this is a 0 and we wiped out an extra term here, I'm going to bring down the next 2 terms. I'm going to also bring down the minus 100, and then the next thing is going to go right there because I'm skipping this part. Okay, let's see what happens when we do that. Here goes. What does it take to turn x squared into negative 10x squared? Well, I would say negative 10. Okay, then you get negative 10x squared, negative 10 plus 60x. This and this is negative 100. Okay, subtract that. Okay, so, but I'm tricky. I don't just subtract, I add the opposite. So I make this plus, plus, minus, plus. This is nothing. This is nothing. Oh my God! Oh my gosh! Nothing! I can't believe it! Oh my gosh. No remainder. I must have did everything right. Yes! Math works. I can't believe it. Yes! That also means the other two roots must be sitting inside of that guy. So watch, x squared minus 10 equals 0. The other two roots are there. How would I solve that? Well, I could plug it into the quadratic formula. Let me just say that. This is not what I'm going to do, okay? But I could plug it in the quadratic formula going A is 1, B is 0 because there's no x term. It's like 0x, right? And C is negative 10. I could plug that into the quadratic formula and that would be just fine. Everything should work out fine as long as I simplify after I do that. But I think there's even a better solution, and that is to add 10 to both sides. And then x squared equals 10, right? And then you say, hey, how do you get rid of x squared? Well, you square root both sides. Don't forget! That's right, plus or minus. How about that? How about that? Can you believe it? Oh yeah, x equals plus or minus root 10, which notice that's two answers, positive root 10 and negative root 10. So what's the entire solution set to this? It's gonna be these two guys, 3 plus or minus I, and then also these two guys, plus or minus root 10. Notice that is 4 solutions, and it's a 4th degree equation. How about that? Can you believe it? Now, these were by far the two most involved problems I'm going to work out from that assignment. Number 22, even though it's a higher number, in fact, number what? You know it. Yeah, that's right. So that's what we're going to do. Now, let me draw a line here just to separate this garbage. Okay. Now, number 22 is basically similar to 2. They're saying create an equation that has these guys as answers. Now, it looks like it might be a 2nd degree equation because there's 2 roots, but realize these are both complex. They both have i's in them. So that means the conjugate root theorem applies. So if 1 plus I is a root, then 1 minus I also has to be a root. If 2 plus I is a root, 2 minus I has to also be a root. So actually, this is going to end up being a 4th degree equation. Okay, now, what do I do here? Well, I just do doubles of what I did right here. Okay, I just go, what is the sum? What is the product? In fact, oh no, it's not the same, never mind. Okay, sum is 1 plus 1 is 2, because the i's cancel, right? Their product is, if you multiply it out, the product also turns out to be 2. I don't want to take the time to FOIL it out, but if you FOIL it out, you find out the product is 2. Okay? Then how about here? Well, their sum is going to be 2 and 2 is 4, because these cancel. The product there turns out to be 5, okay? I'm just telling you, I've showed you how to work these out. You have to FOIL them out to get the product. That's what it turns out to be. So here's what the polynomials turn out to be. You're gonna have x squared minus 2x plus 2 for this guy. You're gonna have x squared minus 4x plus 5 for this guy. And then the worst part of it is, now you have to multiply all that garbage together. So here's how you do it. X squared times this, this, this. So x squared times x squared is x to the 4. X squared times minus 4x minus 4x to the 3rd. X squared times 5 is 5x squared, okay? That's x squared times by everything. Now, let's do negative 2x times everything. Negative 2x times x squared is negative 2x to the third. Negative 2x times negative 4x is plus 8x squared. And negative 2x times 5 is negative 10x. And then finally, let's do 2 times each of these. 2 times x squared is 2x squared. See, I'm lining up all the x squareds. 2 times negative 4x is minus 8x. 2 times that is 10. Now, add all of the garbage together. Can you believe it? Everything. X to the 4, minus 4 and minus 2 is minus 6x to the third. The 13 and 2 is 15x squared. This is minus 18x plus 10 equals 0. And there is a 4th degree polynomial that contains those 4 roots. That's how that works. Okay, those are, that is the problems from homework 49 worked out, at least 4 of them that I was going to show you. Now, homework number 50 is mostly going to be a review of all this stuff we've done from chapter 8 in the book. Okay, it's going to be mostly a review, but there's one new thing coming your way. I'm going to show that to you right now. It's pretty minor. Let me show it to you. Basically, actually, I need to turn it on here. It's going to be a problem that looks like this. Right there. Okay, there is a thing called the rational root theorem. That's what we're going to learn right now. The rational root theorem. Here's how the rational root theorem works. It says if there is a rational solution to an equation, right? See, because there's an equation up there. In fact, that's a 5th degree equation. Okay. If there should be 5 solutions to that equation. A 5th degree equation should have 5 roots. But they could be real numbers, they could be complex numbers, they could have i's in them, they could not have i's, they could have square roots, they could be irrational, they could be all this different kind of stuff. But what the rational root theorem says, first of all, what are rational roots? Rational means fractions, right? So if you got fraction answers to this, if you got an answer that's a fraction, like say 2/3 or -3/8 or 5, right? Any integer numbers also, because you can make it 5/1, or -1/2, right? These are all fractions, right? These are all rational solutions. If there is a fraction or rational solution to this equation, it's going to be of the form, this is what the rational root theorem tells you, it's going to be of the form, actually, let me write this out so I can circle it for you. Okay, this is x to the 5th minus 5x to the 4th minus 3x to the 3rd plus 7x squared plus 2x minus 12 equals 0. Okay, if that equation has a solution that is rational, because not all equations have rational solutions. Some of them just only have complex or only have irrational or whatever. But if there are rational solutions to this, it's going to be of the form factors of the constant on top over factors of the leading coefficient, in this case just a 1, if there's nothing in front of it, it's a 1 on bottom. So here's what the answers will possibly look like. Plus or minus all the factors of 12 on top. So watch, 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5 doesn't go into 12, 6, right? And 7, 8, 9, 10, 11, those don't all go into 12, plus 12. These are the factors of 12. 1, 2, 3, 4, 6, 12. Factors of the 12 on top over factors of, in this case, just 1 on the bottom. Now, what if this was a 3? Then I'd have plus or minus 1, and plus or minus 3. Then you make every single possible fraction you can out of these tops and these bottoms. Well, when the bottom is just 1, then these guys just turn out to be all the possibilities. So if it says list the possible rational roots of these equations according to the this equation according to the rational root theorem, the answer would just be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. That means if there is a rational solution to this equation, it has to be on this list. It means 5 is not a possible solution here, right? 5 is not on my list. No fraction, 1/2, 3/8, none of those are a possible solution to this. If you try them, they're not going to work. If there are rational solutions to this, they have to be on the list. Now, it doesn't mean that there are rational solutions. You may try all of these, and if none of them work, that means then there's no rational solutions for that equation. But if there are rational solutions, they would have to be on this list, okay? So, what does that mean? Well, how does that help you solve it? Well, before we knew the rational root theorem, how many possibilities were there if I just start trying numbers? I could try 1, I could try 2, I could try 3, I could try 4, I could try 5, I could try 6, I could try all their negatives, I could try fractions. How many choices are there? Infinity possibilities. Guess what? I had infinity possibilities, but now because of the rational root theorem, I only have, watch, 2, 4, 6, 8, 10, 12 possibilities. I've narrowed it down from infinity possibilities down to 12. That's pretty good. You know what the bad news is? The bad news is there's 12 possibilities. That means I may have to try 12 things before I hit, because if I may try them all and none of them work up till the very last one, or I may try all 12 and none of them work, then I say, oh, I guess there were no rational solutions. So it's still not that great because I may have to try up to 12, but I may get lucky and find 1 or 2 of them on my first couple tries. So hey, at least it narrowed it from infinity to 12. So, but on tonight's homework, I'm not gonna have you actually solve these equations. I'm gonna have you just list the possible rational solutions. Okay, I will. I think on next time I will. I'll actually solve one doing this, but I'm not gonna make you actually solve them. I'm just gonna make you find the possible rational solutions. Let's do one more like this. Okay. Boom. Wait, no, wrong direction. There we go. This one. Okay, same question. I'm going to use the rational root theorem to find the possible rational roots of this equation. Here it is, -5 x to the 4th plus 7x to the 3rd minus 8x squared plus x plus 6 equals 0. Okay, there we go. Now, first of all, it doesn't really matter that this is negative, right? I could divide through by -1, both sides, and make that positive. So I don't really pay attention to the minus or plus here or minus plus here. I just look at the numbers themselves. I don't worry whether they're positive or negative. Now, according to the rational root theorem, then the factors of this number, of the constant on top, which is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are the factors of 6. The factors of the constant on top over the factors of the leading coefficient on bottom, plus or minus 1, plus or minus 5, right? Because don't worry about the minus, right? Just the number 5. 1 and 5 are the factors. Now, I take every possible fraction I can make with these tops and these bottoms. I like to do it in a systematic order. Here's how I do it. I do all of these guys over 1, so plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1, there we go. Now over 5, plus or minus 1/5, plus or minus 2/5, plus or minus 3/5, and then plus or minus 6/5. So, there you go. If there are rational solutions to this equation, this fourth degree equation. It's going to have 4 solutions. If any of those are rational, they're going to be on this list, right? Or if 2 of them are, or 3 of them, maybe all 4 of them are on this list, or maybe not. Maybe none of them are. There's no guarantee that any of these are going to work. All that the rational root theorem tells you is if there are rational solutions, they would have to be on this list. For instance, 3/4 is not on this list. So 3/4 is not a possible rational solution. You'd be wasting your time trying to see if 3/4 is a root here, because it would not be. The only ones that even have a shot at being the answers are these guys. Okay, that's what the rational root theorem tells you. So you say, well, then how would I use these to actually solve the equation? Well, what you would have to do is start trying them with synthetic division. Try one. I'm not going to go through this right now. I will do one next time like this. But you go try one and do synthetic division. But how do you know if it works? Do you get 0 for a remainder? That's what would, if you get anything other than 0, then it's not a root. And then you just go on and try the next one if you don't get 0 there. Until you get 0. If you get 0 there, that means that would be a root. Okay, that's how it works. But I'm not making you do that part on this homework. I'm just having you list what the possible rational solutions are. That's going to be the first part on tonight's homework. In fact, let me just show you tonight's homework so that you can see, because you're ready for it now. Boom, right there, homework number 50. First page, page 384, oral exercises 5, 7, 9, and 11. Now, oral exercises tell you find the possible rational solutions. Then on that same page, if you go to the written exercises, they say now go ahead and use that to solve the equations. I'm not making you do that part on it right now. I'm just having you list the possible rational solutions. If you want to try to go ahead and solve it just for fun, go ahead, but you don't have to. Then page 381, self-test 2, 1 to 7, all except 6A. That's just a rehash of all this stuff. It's like a summary of all the stuff we've been learning in chapter 8. Same thing with the chapter review, page 397, 398, chapter review, 5 to 11, all except 7. That's also review. So most of this assignment is review. So enjoy, and I will see you guys next time.